In this video, let us see about the fluid statics. Basically, we will be seeing about hydrostatics. So, fluid statics. The statics is called. The statics is defined as analyzing when rest. When a substance is rest, and we analyze that substance, that is called statics. Analyzing the fluids at rest is called fluid statics. This fluid can be divided into two categories, as you know. One is liquid and other is gas. So statics that is dealing with liquid is called as hydrostatics, and the statics that is dealing with gas is called as aerostatics. We have only hydrostatics in our syllabus. We will be studying about hydrostatics only. So in this hydrostatics, there is an important term called hydrostatic pressure force. Hydrostatic pressure force. In last videos, we have seen about the hydrostatic pressure that are exerted by the liquid molecules. That is hydrostatic pressure. So due to this hydrostatic pressure, the force will be acting on the substances that we place in the liquid. So if this is the free surface and I placed any plate like this, and due to this hydrostatic pressure force, there will be pressure distribution on this in this way. So this is the upper point and this is the lower point. Here the force will be acting more, and this will be the pressure force distribution. So this is hydrostatic pressure force, and this hydrostatic pressure force has no shear stress. No shear stress will be acting, and only normal stress will be acting. Normal compressive stress, that too compressive stress. So no shear stress will be acting. This is only in case of rest. When the fluid is at rest, this is applicable. So if we consider this, there will be no shear stress acting on this body and only normal stress, and from here it will be in this way. Only normal stress will be acting, no shear stress in this direction will be acting on this body. Now let us see we have seen how the pressure force distribution will be acting on that body. I'll draw it again here. So here small amount of pressure will be acting. So in this way it is distributed. So what will be the amount of pressure, amount of force that is acting on this? That is given by F is equal to W H bar. This is the pressure into area. It gives us the force. So what is this area? The area on which this is acting. If you see from, if you look this substance, look this plate from here in this view, it will be like this. So this is the, for this area is equal to, let me say this is B and this is B. This is B and this is D. So area is equal to B into D for this rectangular plate. So F is equal to W H bar into A. So what is H bar? H bar is, there will be a center of gravity. Center of gravity for this. So this is the center of gravity of this plate. And the height of center of gravity from free surface is H bar. H bar. And what is the effect of this force, where will be the effect of this force acting? That is at a point below the center of gravity, that will be acting. This is the force that is acting, and this force is equal to WA h bar. So the force acting will be this h bar, but the force where it is acting, the effect will be somewhere here below the center of gravity. This is because the pressure distribution varies and it is not constant, so that will be somewhere below it. And let me say that this is H star, and this point is called as center of pressure. Center of pressure. If we see that, let me say this angle is theta. If you look in the formula of this hydrostatic pressure force, there is no theta. So the angle does not influence the value of hydrostatic force. And what else? So now, what is this center of pressure? Center of pressure is given by, there is a formula for center of pressure, which is h bar plus I GG x by a h bar into sine square theta. And what is this IgGx? That is moment of inertia about x-axis and about okay. So here I am considering this as origin, and here it is z-axis, here it is y-axis, and a axis projecting out of the screen is called x-axis. So I can represent this here. So if I look in this view, it will be, so this will be x, and this will be y. So x and y axis in this view, for this figure, in this view, this is x and this is y axis. So the x axis is here, and the parallel an axis parallel to x axis is passing through this center of gravity. So about this axis, this is the moment of inertia IgGx, an axis parallel to x axis which is passing through the center of gravity, and about that axis moment of inertia is IgGx, and theta is the angle that is making with the horizontal surface, so that is h star. For different cases there will be different h star or different center of pressure. If this is the free surface, and the plate is horizontal now, in this case the theta is equal to 0, and h star will be h bar plus IgGx by a h bar sine square theta. Sine theta is 0, so this total value will be 0. So h star is equal to h bar. So h bar will be this one, and the pressure distribution on this will be constant since there is no depth. So the pressure distribution will be constant on this horizontal plane, and here F is equal to WA h bar, and this W is specific gravity, as you know. And the next is, if the plate is vertical, So this is the center of gravity, and the height is h bar, and there will be center of pressure which is somewhat down, and this height is center h star. So the pressure distribution will be from here this will be the distribution, and where will be the force that will be acting, and it is here. The effect of force will be here. F is equal to WA h bar, and where will be this acting? Here only, at the center of gravity it will be acting. So this is equal to WA h bar. And for different shapes, the different h star is given, and we will see about it now. Just remember this formula. This is free surface, and there is this rectangular surface touching this free surface, and this height is h. It's not h bar, it's just h. So h star is equal to 2h by 3 for this vertical plate, and next there is inverted triangle, and for this is h star is equal to h by 2, and if the triangle is placed like this, and this is h, then h star is equal to 3h by 4, and if there is circle, and the circle's diameter is d, then h star is equal to 5d by 8. And next, if there is semicircular plane, and the diameter of this is d of the semicircle, h star is given by 3 pi d divided by 32. Next, a quarter circle is there, and the diameter is d, so this radius will be d by 2, and h star for this is 3 pi d by 32, same value as of semicircle. And now finally there is trapezium in this way. If there is trapezium, and this is A, this is B, this is H, H star is equal to H into A plus 3B divided by 2 into A plus 2B. So remember this, all values.